Let's start IntelliJ idea. Today we are going to discuss continuation part of RDD. So yesterday we discussed RDD. What is RDD? What is RDD? It is a data storage object in Spark core. It is a data storage object in Spark core. We can create RDD in three ways. One, by parallelizing local object. By parallelizing local object. Second one, if you apply any transformation on RDD, you will get another RDD. And third one, by loading file using text file method of Spark context, we can create RDD. So in three ways we can create an RDD, right? Next one, yep, ours is in this one Spark and Scala batch 3 workspace, right? Under workspace Spark 4. This one is our project. So let's open that one. Let's open that project. Okay. So yesterday we discussed how to create an RDD, and yesterday we discussed one more point. We can uh, we can apply operations on RDD, right? So we can apply two types of operations on RDD. One is transformation, and another one is action. We can apply two kinds of operations on RDD: transformations and actions. What is transformation? Transformation convert one data set to another form, one form to another form, which takes data set as an input and transform into another data set, which takes data set as an input and transform into another data set. So this is called transformation. So we give input as a data set to transformation. It will convert to this data set into another data set, another data set. Every transformation return type is RDD. Every transformation return type is RDD. So we can apply n number of transformations on data set. We can apply n number of transformations on data set. So transformation means transforming one form to another form. Transforming one form to another form. So once we complete the transformations, then we apply actions. Action may be storage action, action may be result, action may be displaying data in a console, counting records, like that. We have multiple actions. Each action returns results. Each action returns results. Each transformation returns RDD. Each action returns results. Action not returns RDD. Only transformation returns what? RDD. Only transformation returns RDD. Okay. So we have different transformation functions: map, flat map, reduce by key, group by key, filter, filter by key, filter by range. There are multiple transformations. And next one, action. Action means first it is an operation which takes RDD as an input and gives value or collection, or it moves RDD to some storage system. An action is an operation which takes RDD as an input, RDD as an input, action takes RDD as an input and stores RDD into specified location, or it performs operation and returns result, or it returns a collection, or it returns just a value. So every action returns value, or it saves data set into or RDD into some location, but action not returns RDD. Action not returns RDD. Okay. There are multiple actions in our Spark. So few of them. Count is one action. What is this count action do? It will take RDD as an input and finds number of rows in that RDD. Collect function, collect action reads each row. Collect action reads all rows, not each row, reads all rows. Take action, take action, take action reads specified rows. Take action takes parameter. So there we pass number of value, number of arguments. So take action takes one argument. Here we specify how many rows we want to read. Next one, save as text file action saves RDD into specified location. It may be local storage, it may be HDFS, it may be S3 bucket. So it will save text file into specified location. Okay. See, whenever we apply transformation on any dataset, immediately it will not load file into memory. Immediately it will not perform any transformation of operation in dataset. What it will do is it will create one graph in Spark. It will create for every transformation internally it will maintain one graph. That graph name is called lineage graph. So immediately data is not loaded into memory. When you perform any transformations, when you perform any transformations, immediately it will not load the data into memory. So this concept is called lazy loading. So it will not immediately load data into memory. When transformation is executed, whenever we apply action on any RDD, when we apply action on any RDD, it will execute all the transformation, dependent transformation. Example, we are applying action on RDD3. RDD3 created based on transformation 2. So transformation 2 applied on RDD2. Then it is created RDD3. So RDD2 is created based on transformation 1. Transformation 1 is applied on RDD1. RDD1 is loaded based on sc.text file. By loading file, it is created. So when we apply action on RDD2, RDD3, it will execute this entire flow. It will execute this entire flow. Okay. So this complete information is stored in one graph is called lineage graph. I will show in web UI lineage graph so that you will understand clearly what is lineage graph. So this lineage graph is executed by DAG scheduler in Spark. DAG means direct acyclic graph. So direct acyclic graph maintains this lineage graph. Whenever we create multiple transformation, internally Spark maintains this lineage graph under DAG scheduler. So once we apply any action on any RDD, what will happen? It DAG scheduler executes this entire flow. DAG scheduler executes this entire flow. Example, let's see. I'm loading one text file using val rdd1 sc.text file 1. Whenever we use sc.text file, it will load RD, it will create RDD. On this RDD, what I'm doing, I'm performing some map transformation. So this transformation creates another RDD. On this RDD, I am executing action called. On this RDD2, I am executing action called collect. So whenever we execute collect action, then to execute this RDD, it requires RDD1, right? To execute this RDD, it has to load file from specified location to RDD, right? So this complete lineage graph. This lineage graph is maintained by DAG. So once we execute this action, then it will execute complete this flow. And once this action is completed, result is removed from memory. Once action is executed successfully, once action returns the results, then complete this flow is removed from memory. Again, if you execute action on RDD2, again it will execute flow from starting to RDD2. Once action is completed, it will remove this data from memory. If you again execute, again it will start from start to RDD2. That's why we have one special concept in Spark, persistence. So if you persist RDD2, it will not execute loading file into RDD1, RDD1 to RDD2. Then directly if you execute any action, directly it reads data from RDD2 because this is persisted. So we have a concept called RDD persistence. We will see what is RDD persistence later. So RDD persistence means we can save RDDs permanently into memory until application is available. Permanently means until application is available. Okay. RDDs are created when we execute action. Once action is successfully completed, then Spark removes RDDs from memory. Graph is presented in scheduler, DAG scheduler, but memory allocated for this RDD is removed. Once the result is completed, it removes that memory. Okay, let's see flow of execution. So there is one more graph, lineage graph. I loaded file into RDD1. From RDD1, I applied some transformation. I got RDD2. On RDD2, I applied action. Next, RDD2, I created RDD3. RDD3, I created RDD4. So this is my flow. In this flow, when we apply action on RDD4, then it will execute flow first. To execute action on RDD, it requires RDD3, right? RDD3 is dependent on RDD2. RDD2 is dependent on RDD1. RDD1 is dependent on loading this file into RDD1. So DAG scheduler execute this complete flow and finally execute action. Once action is completed, removes memory allocated for this RDDs. Did you got this point? Do you have any queries up to now? Did you understand? So by default RDD, the data storage object are immutable. The default RDDs are immutable. That's why if you apply any transformation, it is creating new RDD. So first point, RDDs are immutable. If you apply any transformation on RDD, it will return another RDD. Okay. So here, this example, loading text file into X1. On X1, I executed transformation. On X1, I executed transformation 2. So this is RDD1. RDD1, I executed transformation 1, transformation 2. First transformation, I got X2. Second transformation, I got X3 RDD. On X3 RDD, I executed action. So this is the file loaded into X1. From X1, we created X2, X3. On X3, we executed action 1. Once we execute action 1, it loads file into X1, X1 to X3. then action is completed. Once action is completed, it will remove all these memories. Next, what we will do, we created x4 by applying transformation on x2. So we applied action on x2, we got x4. Then on x4 we executed action 2. Once we executed action 2, then this is the flow. It loads file into x1, x1 to x2, x2 to x4, then action applied. Once action is completed, result is generated, then it removes this flow. Okay. Next, we are creating x6 RDD by applying transformation 5. So transformation 5. So x2 we got x6 RDD. On x3 again we executed action 3. When we execute action 3, flow is x6 to x2, x2 to x1, x1 to file. So first file is loaded to x1, x1 is converted to x2, x2 is converted to x6, then action is applied, it will generate result. Once the result is generated, it removes all these RDDs memory from memory. Because memory is very important, right? If everything is presented in memory, for new actions, for new transformations, we cannot see memory. Memories are very less. Compared to hard disk spaces, memories are less. Okay. So this graph is called lineage graph. DAG scheduler will schedule the flow of this execution of actions. To see the graph, we use sc.ui.web URL. Whenever you create a Spark context, it will create a web URL. If you want to see, if you forgot that web URL, then you can type sc.ui web URL. Then you can see it will generate web URL. Copy that URL and paste that URL into browser. You can see this lineage graph. You can see this lineage graph, and you can see action information. If you apply any action, how much time it is taken. If you want to know how much time it is taken, then go to that web UI and find that statistics. Find that statistics. Okay. So DAG, we have two kind of DAG. It maintains two kind of graphs: directed graphs, undirected graphs. Directed graphs and undirected graphs. But most of the times we have directed graphs in DAG because RDDs are dependent on another RDD. So we have directed graphs. It maintains directed graphs. And one more important point about here is, assume we are running multiple Spark applications. Assume we are running multiple Spark applications. For every Spark application, it will create one separate web UI with separate port number. First Spark application, it will create host name 4040. Second Spark application, it will create host name :4041. Third application 4042. Like this, it will create different port number for different applications. So it is possible to run multiple applications in cluster environment, right, Ravi? We can deploy multiple applications into cluster, right, Ravi? So if you run multiple application, how can we see each application uh, information? How can we see each application lineage graph? How can we see each application transformation information and actions information and log information? Means for every application, it will generate one web URL. If you run only one application, hostname :4040 is the port number. If you run multiple applications, for second application, port number is different. Third application, port number is different. Like this, if you run n number of applications, it will create n number of port numbers. By opening that port number, you can access that application. You can see that application information. Okay. Do you have any queries in this? No? Well, let's continue other one. See, if you observe while creating Spark configuration object, we have specified master name, right? Did you remember? We specified conf.set spark.master and we are saying local, right? Assume my system is i7 system. It contains 8 core processors. i7 system, 8 core processors. By default, 2 processors are allocated to Windows operating system. By default, two processors are two processors. Sorry, core, core. Every processor contain multi-cores, right? Nowadays we are seeing multi-core processors, right? Yes or no, Viren, Hemant? So we have multi-core processors. So in multi-core processors, nowadays are able to process millions of instructions parallelly. So we can utilize that cores and processors. So in Spark application, we can specify number of cores. We can allocate number of cores. So this is one of the advantage of our Spark. I am running Spark application to speed up that application process, to improve the performance of your application. You can allocate multiple cores to your application. Assume if you want to apply 2 cores. So mine is, let me show. This is my system. Click on properties. Here you will see mine is, it is core i7 processor. Core i7 processor. And how many cores it has? So it is i7 processor and 4 cores, I think. It is 4 core processors. I didn't find here. In some other place, maybe we find number of cores. So it is i7 processor and 4 cores. 4 cores. So by default, 2 cores are assigned to Windows operating system, right? Sorry. So remaining we have how many cores? 2 cores. Then here we can specify 2 core, 2 cores. Or if you use star, it allocate all remaining processors, all remaining cores to this application. All remaining cores to this application, so that this application process parallelly very faster. Okay. So what I'm doing here, I have one file called call log data. So this file I have in HDFS file system. HDFS file system. Let me show you where it is located. So I'm starting Cloudera. So in this application, what I'm doing, I'm reading file from HDFS file system. I'm reading file from HDFS file system and performing transformations and actions. Let's start Cloudera mission. So in my mission, I have a Cloudera setup. I have a putty software. I'm connecting this one with the putty. So let's connect Cloudera, and Cloudera is a username and password. So this is my system. So in this, I created one directory name node. In this utilities, browse file system. Let's make this one full screen. Here, let's create one directory. So under Hadoop, I want to create one directory. What is the directory name I want to create is, let create Hadoop fs mkdir. Under root, I want to create qt directory. Under qt, let's first create a qt directory. So in this qt directory, I want to place call log file. So ls, let me check, is there any file? Let's go data here. In this data, we have a call log data. So what I'm doing, cd, let me Hadoop fs hyphen put is a command to place file into specified directory in Hadoop. Hadoop put, what is the file name? Under desktop, there is a data directory. Under data directory, we have call log data, and place this data under root under qt directory. It is placed successfully. Let's open browser. Let's refresh browser. Under root, you will see qt, right? Under qt, we have a call underscore log underscore data. Okay. I want to read this data into my Spark application. So first, what I'm going, click on this SBT. Click on this SBT. Let's wait to start this SBT. Once SBT is successfully started, then what we are going to do, we will type console. This console command starts Scala SBT cell. This console command start Scala SBT cell. Let's wait to start Scala SBT cell. Sorry. So SBT cell is started. Now import org dot apache dot spark dot underscore to import all classes of Spark package. Now create Spark context val sc equal to new Spark context. Spark context. This Spark context object takes configuration object. So I am creating inside this constructor. I am creating Spark conf. Spark conf object. In this we set what? Set master name. Set spark dot master and master name is local. Here I am setting number of processors, number of cores, not processors, number of cores. Number of cores I am setting 2. Dot set application name, spark dot app dot name. I am setting application name. What is my application name? Spark app. Spark app. Okay. So we created Spark context object. Let's wait to create a Spark context object. So it is created Spark context object successfully. Next, what I'm doing, set log level, sc dot set log level, set log level. I'm setting log level is warning. Now load file from HDFS to RDD. Val RD1 equal to sc dot text file, and we are loading file from HDFS file system to RDD. So HDFS colon slash slash IP address. What is the IP address? 192.168.0.6, right? Let me open here. ifconfig, type ifconfig to know the IP address of your mission. So 192.168.1.106. 1.106. 1.106 colon 8020 is a HDFS file system port number class under root qt directory. There is a file called call underscore log underscore data. Call underscore log underscore data. So this is the file. We are saying read this file and place into RDD. Now RDD is created, RD1 dot count. It will return number of records presented in that file. Let's wait to complete this action. So we got some error. Let's see what is the error here. So it's saying input output error, constructing remote block reader. No further information. Input output error, remote block. So this one is correct, right? HDFS colon 192. This is the port number 8080. So directory name we passed. Let me search this one. Unable to launch master locally. Okay. Yep. Let me check how did I created this one. Local off to. Perfect. Let's use star. So this one is not a problem, right? So only one Spark context may be running in JVM. So already running successfully. So that is a not problem with our issue. Maybe problem with this Cloudera system. So let's restart this one. Restart guest. Until this restart, let's connect with the local call log file. Batch 3. Here we have a data, and I'm placing call log file, call log data, call log data into our working directory, our working directory. Then I will pass this file as an input. Until that time, until that restart, what I'm going to do, I will pass my local file system path, call log data, call log data. Okay, press enter. Invalid escape character. Yep. So here we need to use escape character. So I created RDD. Now RD1 dot count. So local file is loading successfully. Only one thing is we will check HDFS file system. Let's wait to finish loading HDFS file system into our RDD. Sorry. Let's find IP address of this mission once again. ifconfig. Yep, it's 1.106, right? Let's once again create RDD by loading call log data. So this is call log file, right? So what I'm doing, RDD, RDD2. I'm giving different name. Instead of thinking we are getting from previous one, I given different variable name, RDD2. RDD2 dot collect the sorry, in collect will take all the data, right? Take of two records or 10 records. If once again what I'm doing, I'm stopping this one. Okay, let's start SBT cell once again. Console. Try to import the package. Import the package. Let's create a Spark context object. Spark context object. So here what I'm doing, Spark dot master, Spark dot app name. Let's use only local. Let's create RDD by loading HDFS file. Before that, let's set sc dot set log level warning. Next, RDD2 dot count. Yep, this one I will show in tomorrow class. I'll resolve this issue why it is not connecting HDFS file system. I will resolve this issue tomorrow class. Tomorrow class I'll show clearly by connecting HDFS file system and accessing that one into our local. Okay, so no worries about this one. Tomorrow class we'll see this one, because every day I'm using HDFS file system in my Spark application. So I'm using this HDFS file system in my Spark application. Today something problem with master. I'll resolve this issue and I'll show you tomorrow. No worries. But we seen, right? We loaded local file system into RDD and we performed count operation and we performed collect operation, right? So today I'll show you only local file system concept. So I'm creating local file system, loading local file system into RDD. Now RD1 dot collect. Before that I'll show you take action, and here we pass number of records. Then it will read only those many records. So it readed all 10 records, but I want to print that one. So for each println. So what I'm doing, I'm passing these 10 records to for each. For each reads each record and passes to println. So this is the 10 records. 10 records. If you use collect one, collect reads all the records. Collect reads all records and passes that records to for each function. For each function reads each record and pass it to println. So it will take longer time because we have many records. So it will take longer time. So you got the point, right? So we can use local and we can pass number of core processors. We are loading HDFS file into RDD. Then what will happen? If it will create a number of partitions, we are not specifying number of partitions, right? But it will create a number of partitions based on your number of processors. So default number of partitions are 2, because we have assigned 2 core processors. If you run same program in cluster, it will create partitions based on the number of unique blocks of that file. If file contain 3 blocks, it will create 3 partitions, unique blocks, not replication blocks. It will create partitions only for unique block. Means block 1 may have 3 replication, right? But it will create 1 partition for block 1, 1 partition for block 2, 1 partition for block 3. So in this way it allocate memory. Memory in RAM. Okay. So tomorrow class what we will do, we'll discuss some more important points about these transformations and actions. And tomorrow class I will clearly show you. I will show you to load HDFS file into RDD. Then we will apply transformations actions on that RDD. Okay. So that's it for today. Do you have any queries in today class? Okay. So that's it for today. We will meet tomorrow and we'll discuss some more important concepts of RDD, transformations and actions.